For problem 4, we're going to have to do the same exact thing that we did for problem 3. So now let's rewrite the final formula that we're going to have. So it's going to be the gradient of our function at point P times the vector unit A. So this time I want to first of all find out what's the vector unit A. So we can keep it for the end and don't come back all the way up here. So it's going to be vector A over the magnitude of A. It's going to be I plus 2j times 1 over the magnitude of A, which is going to be equals to 1 plus 2 squared, which is then going to equal to 1 over square root of 5 times I plus 2j. That's going to be our A vector. So let's go back and let's find the gradient of our function. So it's going to be equals to the gradient of function in terms of x along the I direction plus vector of function y along the j direction plus the gradient of our function in terms of z in the k direction. So it's going to be, in terms of x, we're going to get the same exact thing because we're going to derive the e to the power of x, which is e to the power of x. So z e to the power of x cosine of y, all of this is in the I direction, plus, let's derive the y, so let's derive the cosine, therefore we get a negative sign of y, I'm going to put it in front, and everything else remains the same because it's a constant at this point, plus, and then we derive in terms of z, and we get e to the power of x cosine of y in the k direction. So that's our function. Let's find our gradient. Let's find our gradient at point P. That is 0.10 and pi over 3. Okay. So yeah, 1, 0, and pi over 3. So here we get the same thing we just found. Copy and paste. Oops, let me bring a little bit up so it's better. Okay, at point we just said 1, 0, and pi over 3. So let's substitute the values. For x, we substitute 1, for y, we substitute 0, and for z, we substitute pi over 3. So we're going to have a pi over 3 times e to the power of 1. So we're going to have times e. Cosine of y, and our y is going to be equal to 0, so it's going to be equal to 1 in the I direction. Plus, then we're going to have a negative sine of y. Sine of y, in our case, is sine of 0, which is going to be equal to 0. So the whole thing goes down to 0. And then we're going to have our e x power cosine of y. And for our x, we put 1. So it's going to be e, in the direction, plus j direction. Okay. Plus e to the power of x, which is going to be equal to e. And then cosine of 0, which is equal to 1, so e in the k direction. Now we have to multiply by our vector a, and that means we're going to have to rewrite this thing. The gradient of our function at point P times the vector field a, which is going to then be equals to, let's check, we're going to have 1 over 5 times pi over 3 e. Because everything else goes to 0, because we don't have a k in our a hat vector, and we don't have a j in our gradient of our function at that point. That means that it all goes down to 0 except for the I direction, like we said before. So our final answer will be, let me make sure of one thing first of all. Okay. Can't find if the solution, but I am fairly confident we are going in the right direction. Yes, we are indeed, because, well, let's rewrite the whole thing just so you can see it too. We're going to have this, copy, paste, times our direct a hat vector, which is this, copy, and paste right here. Then is going to go to the I. We're going to have 1 over square root of 5 in front of everything. Then I, which is 1, well, our pi over 3e times 1, so pi over 3e, plus we have 0 for the j, so 0, because here it doesn't matter to 2. And when we have a for e for the k, but we have a 0 here, so we're going to have plus 0 again. So our final answer will be pi over 3e over square root of 5. That is our final answer. Now we can write it a little bit better, of course. We can write it as pi e over 3 times square root of 5, and this is our final answer.